financial scenario or things like that. One thing, let's talk about the financial gig. A couple things that these are done incorrectly. So that is actually a diagram of what the stock market has done since the start of the stock market back in the early 20s. Okay? So, yeah, this could be 2008. Yeah, this could have been 32, or 1930, 1932. It could have been, yeah. So, what do you notice about the stock market? If this is time in years, and this is money, what do you notice?
It's increasing.
It's increasing. Now, see this right here? What they'll do to make things worse than it really is they will change how you look at this. And they'll be like, take a look at this, which is just this region right here. And they want people to react to it. People react to pictures. People panic. Okay? You guys ever heard the term slow and steady wins the race? Mm-hmm. Truly, if you invest money throughout your life, starting from your early adulthood till the day you retire, you're going to do just fine. Why did people lose a lot of money here? Any ideas? It was a recession, but why did they lose money? I can tell you I lost nothing. Yeah. They panicked. What did they do when they panicked? Sold it. Like, oh my gosh, I got to sell everything now. Liquidated. I know I'm going to take only 30 cents on the dollar of what I put in, but I'm going to take out what I can get because it's going to go away. No, it's not. If it does go away, having your money is the least of your concerns. Okay, so people panicked here. And yes, were financial accounts worth less at that time? Yes. But I invest, and just one idea. I invest in something called mutual funds. So how this mutual fund works is this. I put money in every month. The mutual fund will pay me back a dividend, which is basically like I am giving a large corporations a loan of my money, and they will pay me a portion back, kind of like interest would work. So I can do one of two things with a dividend. I can take the money to me, or I can take the money and reinvest it. Well, if I take the money and reinvest it, I have my source and the dividend source reinvested into itself. So let's say this mutual fund, so you can buy a share of a mutual fund. And a share of a mutual fund is a small inkling of it. I mean, mutual funds are worth hundreds of millions, if not billions of dollars. So when you invest into it, you invest a small portion of money, but your money that you're investing is acting like the big boys in industry. Okay? Meaning, the mutual fund is going to start lending out money. Now, do they know that your $200 you're putting in each month, or your $500 each month, or your $60 each month? Do they know if that's part of the multimillionaire's money or your money? They have no idea. So what they do is they pay back per dividend some sort of share. And this is some sort of percent of money. Now, let's say this mutual fund here is worth, $200 per share. And here, it's worth $100 per share. Two things happen that are really good. And they're really good for people who realize slow and steady wins the race. So if this is $200 a share, and let's say I invest $1,000 every month into a mutual fund, how many shares would I have been able to have bought there? If it's $200 a share and I invest $1,000 a month, how many shares could I buy? 5. So when it was here, I could buy 5 shares. When it was here, how many shares could I buy? 10. I bought twice as many shares. And each share that you buy pays back a dividend. So now, as the market is here, and I was able to buy more here than I was here, it's looking really, really good. Now, you're going to get the person who's always frightened of the sky falling. Yeah, but you lose all your money. So let me ask you this. Would you, or sometime in your life, you're going to consider buying a home? Agreed? No? No. Why not? You going to live in a tent or something? Or? Why? You never lived in a house? They're pretty cool. They have SML houses. That's small. I suggested it. It's a great investment. Well, let me ask you this. Let's go on this way. Would you ever own a car? You will never own a car in your life. Will you ever invest in something that costs money?
Why don't you say no?
And if you say no, you're a complete hypocrite, and you're just trying to do this because you're trying to be popular somehow in this fashion. Would you ever go buy groceries? No, I'm just going to absorb oxygen and live. So,
I'm gonna photosynthesize.
So unless you are a single cell amoeba, you're going to invest in something in your lifetime. And you know what you invest in sometimes? That sometimes is going to lose value. The shoes that are on your feet, the pants that are on your body, the shirt you have on your body. You bought at a certain rate. You're wearing it. Awesome. But you couldn't go and sell it necessarily for what you did. Now you're going to get the kid, yeah, but they pay thousands of dollars for jeans in China. Really? Per whom said this? Oh, the internet. Rest my case. Okay. Yeah. If it's a friend of a friend, or if I had an uncle that knew somebody, it's just coming out as a lie. Okay? So, if you decide to buy a home in life, are you taking a risk that that home will be worth less? Could it be? Yeah, if they decide, hey, let's open up a septic tank receptacle place right next door to your house, going, hey, wait a minute. That's stinky. Okay? So the whole thing is, as far as buying homes are a risk. For most people, they will purchase a home sometime in their life. Okay? For some people, they might not choose to get a home, and that's fine. But the thing is, there are certain risks that you are taking when you purchase something. Is the risk worth the reward? I'll tell you what. 12 years ago, the housing market went way up there. I was living in Reno, Nevada. I bought a home that we had been paying a mortgage on for about 6 years. So I still had a considerable amount of my mortgage left, not an uncomfortable amount. And a mortgage is basically a loan I took out because most people don't have that kind of money, 6 figures, to purchase a house outright. Now, some people do, and I get it. I'm not there. And some people have enough money to buy a 7-figure house and 8-figure house, and I get it. So I owed a certain amount on this home. I bought the house for X, and I sold it for 3X. How much did I improve my money? How much? I bought it for X, and I sold it for 3X. How much did I make on my money? 3 times. Good investment? Yeah. Now, some people got bonked in the middle of this thing. I'll tell you what, we moved here. That was when my wife and I and kids moved here. we decided this is a really good time to move because we're never going to get this type of return on a house ever again. Now, some people took a lashing on it, and they got these weird loans that were fictitious money loans. And they'd say, hey, you're going to, rather than having a 3% loan, we can give you a 0.08% loan. And what they would do with that is they would say people are qualifying for a much larger loan than they could actually afford, but because they had things called balloon rate loans, meant you paid a small percent of interest in the beginning, people thought, oh, I can get that. Look at that. I can afford $1 million home while making only $30,000 a year. No, you can't. But they were conveying it this way, and this market crashed. Now, right before it crashed, we sold our home. We moved here when the market crashed, sent all housing prices down. I made 3x on a home in Reno. Moved here when the market came back down. Oh, I bought a bigger home. And almost paid all cash for it, which was really kind of cool. So I'm an anomaly right now. At age 42, I'm now 44, but at age 42, I sent in my last mortgage payment. I outright own my home. People are like, how'd you do that? Well, I got real lucky because I bought a house for X, I sold it for 3X, came out to a market when it had dropped, and was able to put 3X down on to a house that cost 3X plus 10 or something. So that's the secret of what that worked with me. Now, people are like, my dad told me flat out, oh, you're a fool for not having a mortgage. Why? Because you can write off the interest. So what that means is if you were to make, let's say you make $100,000 per year, and I'm just putting a figure out there, if you pay a certain amount in interest for a home, that can lower this rate, which lowers your taxable income, which then says the federal government sends you money back. Is it a 1-to-1 ratio? No. But people feel that this is a good idea to have a mortgage so you pay interest on your home so the government will send you money back. Do you guys want to know another way that you can write off your interest? You can invest in a mutual fund, a tax-deferred mutual fund, meaning you put money in. It lowers your income tax bracket the same way your mortgage does. Let's say you have a mortgage payment of $2,000 a month. So if you don't own your home, you got to put it into your home. If you do own your home, guess what this $2,000 goes to? Your life savings. Good idea or bad idea? I think it's good. Kind of like where I'm at in life. Kind of like things that are opportunities that are available. Now, why do people not do this? They don't start investing. Or they realize, oh, I'm going to retire at 65, so at age 55, I'm going to start saving for retirement. Probably not the best idea. Probably starting about age 25 would be a good time. That way you have 40 years. 40 years could span a pretty good amount of this to invest money. Why is it a good idea? Well, I don't know. I've seen people in retirement that are going, okay, I got to wait till the government check comes in so I can go buy groceries. I don't want my retirement to be that way. Maybe you want yours to be that way. I don't know. I probably not, but maybe. I don't know. So, good idea for an investment or bad idea? This is based on a scatter plot. The scatter plot is based on an exponential function. An exponential function is a function that is raised to the x power. Do exponents grow quickly? 2 squared is what? Put your phone away, Casey. Give it to me. Give me your ideas when. You can pick it up from the dean's office. 2 squared is what? 2 to the third is what? 8. 2 to the fourth is? 16. 2 to the 5th is? Yeah, it goes for 2. Thank you, man. Exponents grow a lot quicker than linear. Okay? So, imagine making a prediction based on data that you know. Is it an educated guess? Yes. What's an educated guess versus a guess? Means you have something to back up what you're thinking. Are all educated guesses great? No. Will they pay off for you? Not always. What are you going to do with it? Depends. So let's talk about this first problem here. So we go 0, 10, 20. This was 30, 40, and 50. And then snowpack. So snow. And this is time and days. So 0, let's see, we're going to go up to 130. So maybe go 20, 40, 60, and we'll do 0 here. 80, 1, 20. All right, so first one's here, 1052. And I saw a lot of you do this the other day, and I thought you did fantastic with your graphs. 30 is 92. 40 is 112. And 50 is 130. So it appears that, and again, I didn't do it perfect. I did not draw it perfect, but did I have a pencil and ruler that I was using? No, I just scaled it the best I could. This appears to have a line of best fit. This appears to form some sort of linear equation. Okay, and I realize that last point's off a little bit. I ran out of space. So we have a line of best fit. Now we talked about last time, if you had a piece of data this way and this piece of data, would these be two good ones to choose for a point? No, it's a different picture. Now, of course, that's not part of it. So what am I going to pick? I'm going to pick two of my points that seem to fall along my line. And so this is 10, 52. And this one was the fourth piece of data, which was 30, 92. And it says, what is the independent variable x? Well, the independent variable x is days. What is the dependent variable y? Well, that's snow. That's in the y-axis. Plot the points on the graph, choose the appropriate scale. Okay, so basically we counted by 10s on the x-axis and 20s in the y-axis. Why did I choose that? Because counting by 1s here or 1s here, we would have just tick marks all day long, and it's not going to represent it. Okay? Write the equation of the line of best fit. So you might have chosen this point and this point. Could someone have chosen this point and a different point? Yeah. Will the equation be slightly different depending upon what 2 points you pick? What do you think? Think about it. If I had more pieces of data that were on either sides of this line, if I had more pieces of data on either side of this line, if I picked 2 different points, would I have a slightly different linear equation? Absolutely. Do I know that? Yes. So let's say you go and you find your equation, and you find it to be like 0.38 x plus 35. And the person sitting next to you finds one and has it like this. Are those pretty close answers? Do I realize those answers should be close because person over here might have picked 2 points, person over here might have picked 2 different points, slightly different? Are those 2 linear equations pretty close? Absolutely. Okay? Now, your calculator, if you get the graphing calculator, is going to do this a lot easier, a lot faster. And there's a test that they use, and it's called the R-squared value, which means the closer your R-squared is to 1.00, the more exact it is. So if you had an R-squared value of 0.38, that means the calculator is 38% sure that the line of best fit is the right line. 38% sucks. But if someone says, hey, this line of best fit fits our data with 98% precision, that's pretty good. Think of it, as an A through F scale. You want a 98% in class? Yes. Do you want a 31%? No. Okay? So that's how you can think of that. And again, we're not there to the graphing calculator yet, but this is how our information is going to go. All right. So if I pick these two, well, first off, is this positive or negative correlation? Do you think the slope of this line would be positive or negative? Positive. So this has positive correlation to it. Okay. What is the slope? Well, based on our information, I'm going to go 92 minus 52 over 30 minus 10. So that's going to be 40 over 20. So we're going to get a slope of roughly 20. Were two of the other points possibly going to get you a slightly different slope? Sure. Is that okay? Yes. As long as you show your work. I mean, the hard thing is when people are just putting in random stuff. Okay, some of you like to never show work, and you're just reaching an infinite region of numbers and pulling something out. I think it's going to be 2. Okay, good. Close enough. It should have been 255,321, but you picked 2. You came close. No, wrong idea. What are the coordinates of the y-intercept? The y-intercept in this case is 0, 35? What does that mean in this situation? Well, that before the first day, before we started counting, we already had 35 inches of snow on the ground. And as the days progressed, we gained more or thicker amount of snow on the ground. Okay? Use your equation to find the snowpack in Wyoming 25 days into winter. Okay? So 25 days into winter is here. We talked about this the other day. What am I doing? So that's 25. If my line of best fit, that appears to be 82. They could have about 82 inches of snow. Do we know exactly yet? No. We made an educated guess. This is called interpolation because it's inside my data. So what I'd have to do is let's find our linear equation. So I use this one and this one. I'm going to call that x1, y1. And so I'm going to do y minus 52 is equal to 20 x minus 10. Distribute. 20x minus 200. Add 52 to that. Excuse me. Oh, that's a minus 148, sorry. Okay. What would be a better way, and that's a subtraction sign, what would be a better way to figure out what value that's for? What do you think? What value is 25? What two values are we using for this problem? What do we graph on? What kind of axis? What kind of axes? I call it the Cartesian plane. It's also called the blank comma blank axes. X and Y. What is 25? X or Y? X. What should I do with that value with my equation? That is y equals 20x minus 148. Plug 25 in where? For x. Sweet. Let's plug 25 in for x. So 20 times 25 minus 148. 20 times 25 is 500. Yeah, good. Is that right?
Yeah.
No?
Yeah.
I don't know. Tell me. No?
Yeah.
2 times 25 is 50. So 20 times 25 must be 500. Good. You got close. minus 140. So 500 minus 140 is 360. Heck, we said it was supposed to be 82 and we got 360. What does that tell us about our information? Yeah, I mean, so we picked 2 points that we thought were good. Okay, is 360 pretty far away from 82? Yeah, kinda. Okay, according to some of you, 2 is close to 255 million, so, you might be right. So, if we picked 2 different points, would we have a slightly different equation? Yes. Is this one off a little bit? I'd say it's off a little bit. That means that our graph might have been tilted a little too much this way versus this way because we picked 2 of the points that didn't really give us the best line and best fit. Okay? How many days into winter will the snowpack be 100 inches? How many days in the snowfall will we be at 100 inches? Appears on my thing, 35 days. 100 inches. 100 goes in what for X or Y? Y. Okay? So I can take 100, plug it into that equation. Add 148. Divide by 20. So 64 days into winter. 64 days into winter's out here according to our data, but that's okay. So I want to go through this problem real quick, and I'm not expecting you guys to know this on the calculator yet, but I want to pull up this graphing calculator, and I just want to show you what the technology will do for you. Okay, and again, you're not expected to know how to do this. I will strongly urge you that the TI-83 and the TI-84 graphing calculator are good calculators to buy. They're not a waste of your time and your money because you will use them. Now, obviously, if you lose it, it's a bad idea. All right, so I'm going to get into stat. Edit. And for L1, I'm going to plug in my time and day. So I get 0, 10, 20, 30, 40, and 50. And under L2, I'm going to plug in my snowpack. So X is L1, Y is L2. So I get 32, 52, 78, 92, 112, and 130. Okay? So I'm going to turn my stat plot on. I want it to be a scatter plot, L1, L2, mark, we'll make it blue. Make sure I have nothing under my graphs, nothing there. I'm going to go zoom stat. So does that kind of look like our picture a little bit? A little neater than what we had drawn. Do you agree? Okay. So I can do this. I can go vars, statistics, find the equation. I want to make sure that I'm using, here we go. Stat. Okay, stat, calculate. I do that one. I want to find the linear regression number 4. L1, L2, calculate. So that's my linear equation. Y equals 1.91 x, that's my slope, plus 35.38 is my y-intercept. Okay? If we wanted to, we could go ahead and put this on a graph. So I'm going to go y, vars, statistics, equation, plot it, graph it, and there's my line of best fit. So that first question said, hey, how much in 25 days? Days was the x component. So I could say I want to calculate an x value for 25. If I do that, it gives me a y value of 83.16. Okay? This line of best fit is a heck of a lot better than the line of best fit that we had used on mine. Okay? If I wanted to figure out where 100 inches of snow would be, I'm going to come in, I'm going to graph the horizontal line, graph it, which is now my red line. And if I find the intersection right there, that's going to give me some good information. So let's do second, calculate. I want to do the intersect of list line 1, line 2. And it's going to give me at 33.8 days, we should have 100 inches of snowpack. Okay? That's using a calculator. I didn't have it turned on for the diagnostics. I could easily have gone second catalog diagnostics. So this is going to tell us, remember I said the closer r squared is to 1 is 99.57, close to 1. Would you like to earn a 99.57% on the final exam? I'd say so. That's going to help your grade. So that means our line of best fit is pretty good. We know our calculator is pretty accurate. Okay, so that's just a brief look into how to work these as far as the calculator. Are you expected to know it yet? No. I'll tell you that second semester we're going to get a lot more into using these graphing calculators. I'd say get one. Go on eBay, you can get them for cheap. Okay? Craigslist. I'm serious. There is no reason to go and buy these calculators, from Walmart, even though they're $80 at Walmart. 80. But if you go on to eBay, I bet you can find them for about $20. And I kid you not, they're very inexpensive. You go on eBay or you go on Craigslist. Okay? Sometimes you're rolling the dice that it might not work. I get it. But, it's just one of those things. So, tomorrow I think we're going to have a small quiz. Not entirely on this. It'll be some line of business. But I'd like you to work on problem B and problem C from our problem set. Cool? Does it tell you what scientific data is? Absolutely. So B and C will be your homework.